In the previous video, we looked at this system here. Well, we gave it some silly numbers. So the moon has a mass of 20, the Earth has a mass of 100, and the distance here between you and the Earth is 300. It turns out that the gravity between the moon is a lot stronger than the gravity between you and the Earth because of this distance here. This distance is so large that it really makes gravity between you and the Earth really small because of this thing here, m1 m2 over r squared. Now, if this number is 300, it's really large. So when you have a number divided by a number that's really large, your answer would be really small. So that's why the gravity between you and the Earth is really small. Here, let's say you have let's look at this system here. Let's say you have a super planet, not Earth. In fact, let's say we've got a black hole. Now, the mass of a black hole is massive. If the moon is 20, we're going to have to give it a really big number here. I'm just going to make up a silly number like this. Okay. If the moon has a mass of 20 kilograms, I don't know how heavy a black hole is. So let's just give it a silly number like this. Now this black hole here, we've got a black hole now, not planet Earth. It has a mass of this. Okay. Now, do you stay on? If you stand near the moon, do you stay on the moon or do you get pulled towards a black hole? So here, let's compare it. On the moon, it would be your mass times the moon. Okay. So it would be 2 times 20 over r squared, which is 10 squared. Okay. The distance between the center of the moon and you, 10 squared. Now, the distance, even though it's 300 now, let's say the mass of you would be 2. By the way, we are comparing the gravitational pull between you and the black hole. Okay. So you will be 2. The black hole will be this. Hang on. 10 million. Okay. 10 million. Divided by 300 squared. Okay. Now remember, this is black hole, this is moon. Do you stay on the moon or do you get drawn to the black hole? Hang on. So let's see. This whole thing here becomes this. Hang on. I'm doing the top. So 2 times 1 is that, and then fill in the zeros. Basically, I'm getting 2 times that big number at the top. Okay, divided by 3 square. 300 squared would be 300 times 300. So that would be hang on. This would be 9 with 4 zeros. Okay. Now I'm going to divide top and bottom by 1,000. Now I'm going to divide top and bottom by 10. So it becomes 2, and then, hang on. So it becomes this, basically. Okay. This now becomes, 40, and then, 10 squared would be 100. Divide top and bottom by 10. So gravity on the moon is proportional to this. Gravity between you and the black hole will be this. So which number is bigger? If you turn this into a decimal, hang on. Which number is bigger? 2,000 divided by 9 equals this number here. Let's say 222, and 4 divided by 10 is 0.4. So you can see this between you, gravity between you and the black hole is much bigger than between you and the moon. So in this scenario here, you would probably you would float towards a black hole. maybe the moon will probably also get sucked towards a black hole here. Um, um, yeah, so because the mass of the black hole here is so much bigger than than the sorry, it's so much heavier than it's so much more mass. The mass is so much bigger, so you and the moon will get sucked into the black hole. My question here is earlier when the mass was say a hundred, why didn't you and why doesn't the Earth get sucked towards the Earth? Um, so if gravity pulls two things together, why is it that the moon does not get sucked to the Earth? Ask your science teacher that. When you're older, you can answer this question. At the moment, I don't think you can. If you want to know, ask your physics teacher. Okay? But yeah, why doesn't the moon get sucked toward? Well, ask your science teacher. Okay?